Say,
Why did you shout like that? And then we'll look at that and hope that you can finish. If you are not able to finish, we continue that next week. But then I'm hoping that next week we can look at maybe arranging a class within the course of the week. I'll leave that on to the course reps to decide on which day will be appropriate for us to look at, because I may be traveling on the weekend, next weekend. So maybe we try and then have a 2 hours in one of the evenings throughout the week. Or we can even have two separate 2 hours for 2 days. And then we can conclude on the course. Um, the wake up now was shouting. We may be looking at these ones and then later on we will start. Let me say we will start the differentiation and then the integration. Wherever we get to, we pause and then we continue when we find time for ourselves. So let's quickly begin with the correlation, where we will be looking at the meaning of correlation and also look at how we can estimate the correlation coefficient or know the correlation between two variables, particularly using the scatter diagram approach, and then also considering the Pearson's product moment correlation coefficient, as well as Spearman's rank correlation coefficient. Then we will also look at how to determine the coefficient of determination, in which case we will term it R square, which looks at how one set of variables come together to explain another variable. Then we can do the application by looking at how correlation can be calculated, looking at the covariance, how two assets move together. And this particularly, you realize that what we ended with last week, where we were calculating the mean squared deviation, it is going to be surfacing here. So we are going to look at how to calculate those deviations, of which we said that one key application is to looking at investment portfolio construction. And then we will also look at how we can use metrics, particularly covariance metrics, to analyze simple correlation issues. So let's start. I want to urge you that, yes, the topic seems a bit difficult and confusing, but then we're moving together. If there is any issue, don't hesitate to raise your hand to draw my attention so that we break it down. It is for that essence that we are meeting. And so if there is any difficulty that you are seeing, then you draw my attention and then we try and then break it down before we go. I believe that if you're able to understand the concepts and we even cover half of the outline, that is better than we rushing through. And so we're trying to make it easier for you guys so that you can relate when it comes to exams, as well as you making use of some of the contents later on in your career. So let's look at the meaning of correlation. When we say correlation, the term correlation simply means relationship. And so once we say correlation, we are now looking at the relationship that exists between variables. And per variable, we are looking at anything in particular. And so there are so many relationships that have become natural with us. And we can easily see that when the clouds form, there is likelihood of rain falling. And so that is the relationship between heavy clouds and the tendency of rain falling. You can also see that when somebody is so much of thirst and we give the person water, the thirst easily quench. And so thirstiness comes with you providing the person with water, and that is the relationship. So is our daily activities also. So whenever we come into contact with two or more variables, correlation is simply explaining that relationship that exists between these two sets of variables. And by definition, because of exam's sake, we are saying we're looking at the degree and the direction of the relationship that exists between two or more variables. And so whenever you define a correlation, the key words are, we are looking at the degree and the direction. By direction, we are trying to explain whether we are going to have a positive relationship or a negative relationship, whether we're going to see the two variables moving in the same direction or opposite direction. When it is negative, then we say that the relationship is opposite direction, in the sense that as one is going up, the other is going down. Then when they are of the same direction, it means that they are all going up and they can all come down at the same time. And so that is correlation. Now, correlation is not interested in looking at the units in which they are expressed. And so, for instance, if we're talking about the law of demand, for example, all things being equal, the higher the price, the lower the quantity demanded. We are not interested in the units of these variables. And so if price is having the unit of Ghana cedis and the quantity is, let's say, kilogram, that is not what we are interested in. We don't necessarily have to get the same units before we can assess the relationship. However, we can do this by just looking at how one variable changes in relation to another variable also changing, and that is correlation for you. Now, when we talk about this relationship, they are really analyzed using the coefficient. And so the correlation coefficient, which is the numerical measurement showing the degree and the strength of the correlation between two variables, is always ranging between -1 and +1. And so we will have a -1 up to a +1 range. And this range tells us the strength of that particular relationship, or the magnitude or degree of the relationship, as well as the positive or negative, also telling us the direction of the relationship. So this slice alone is giving us like more information, where we've been able to explain correlation by meaning, looking at the relationship that exists between two or more variables, and then also stressing on the fact that the relationship do not necessarily consider the unit of measurement of these two or more variables. Again, it is also giving us that numerical measurement, which is the correlation coefficient, to have a range between -1 and +1. And mind you, the negative sign or positive sign indicates the direction of the relationship, whereas the strength or the degree of the relationship is also explained using this particular category. And so whenever we estimate our correlation coefficient, we are saying that you're going to have a perfect correlation. And normally the degree, which is having these characteristics or classification, does not consider the positive or the negative. The positive or the negative talks about the direction of the relationship. And I told you that if it is positive, then we can conclude and say that there is a direct relationship. If it is negative, you can say there is an inverse relationship. Or otherwise, you can even use a positive and negative to say that there is a positive relationship and then there is a negative relationship. However, we have to complement that positive or negative with this degree or the magnitude of the relationship, where we're saying that whether the correlation coefficient is +1 or -1. Here we look at the absolute value. So whether it's +1 or -1, we consider that one to be a perfect relationship. +1 or -1 is considered as a perfect relationship. And if the coefficient is ranging between from 0.75 to a less than 1, remember when it is 1, it is perfect. But anything less than 1 up to 0.75 is also considered a very strong relationship. Then we will have the strong relationship starting from 0.5 to less than 0.75. We have a weak relationship when it is starting from 0.25 to less than 0.5. And then a very weak relationship will be greater than 0. That is anything above 0 up to less than 0.25. However, when your coefficient is 0, it means that there is no relationship between those variables of interest. So whenever we compute and then we have our correlation coefficient, one, we are saying that the coefficient should be between -1 up to a +1. So this one is a guide. Whenever you solve your questions and your answer is outside this bracket, it means that there is something wrong somewhere. So you need to go back and then revise your solution. Similarly, once you are able to fall within, then you consider whether it is positive, negative, and then also you look at these categories so that you can then conclude. Hence, let's assume that you solve your correlation coefficient, which is represented by R, and your answer is, let's say, 0.73. This 0.73, because it is positive, our interpretation is going to be that there is a positive or there is a direct and a strong relationship, because this figure falls in this category. And so there is a strong positive relationship, or there is a strong direct relationship between the variables of interest. Similarly, when we consider R to be equal to, let's say, -0.436, then this one, because it is negative, we're going to say there is a weak, because it is falling in here, there is a weak and an inverse relationship between the two variables. So your interpretation of the correlation coefficient will depend on whether we're going to have a positive coefficient and as well as the classification where that value of the correlation coefficient fall within the classification that we see on this particular screen. Any question? Any question? If there is no question, let's try and then interpret these correlation coefficients. The first one, we have our R to be equal to 0.003. Second one, we have R to be equal to 0.896. Third, we have our R to be equal to -0.708. Who is trying for me? Hello. Yes, Prince.
Okay, Doc, so please, with the I, we can say that the correlation is positive. And looking at the degree, we can say that it is a very weak positive correlation.
Okay, so put it in one sentence and let's see how it goes. So there is
a very weak positive correlation.
There is a very weak positive correlation. Yes, that's very true. Another person should try the second. Rita.
There's a very strong positive relationship.
There is a very strong positive relationship. That's fine. The last one. The last one.
There's a strong negative relationship.
There is a strong negative relationship. That's fine. So we are all correct. And I'm glad that you got the concepts well. Now, let's try and then look at some of the usefulness of this correlation. First, we establish that correlation helps us in our portfolio management or the risk management when it comes to investment, where we can rely on correlation to analyze how risky these investments could be so that we could be able to know which of the instruments to bring together to help us reduce our risk. It also helps us to reduce the range of uncertainties of our predictions, where because of the relationship, you know that normally in our normal human relationships, there could be certain signs that will tell you that this particular relationship is not going to be healthy or otherwise. And so the correlation coefficient usually give those signals or the signs which helps you to know what is ahead of you in terms of likely things that are going to happen, so that you advise yourselves in terms of the predictions that you're going to do. It also contributes to the understanding of consumer behavior, particularly when it comes to demand and supply. You could realize that because of the inverse and the direct relationship between, let's say, price of a commodity and then the quantity of that particular commodity to be demanded, people tend to understand why, all things being equal, if the price is so high, people tend to buy less. And as people are buying less, the producers are also happy and they intend to supply more because that is where they get more profits. And so it helps you to understand why people, particularly buyers and sellers, act in that particular way. Then it also helps to compare the relationship between variables that are expressed in different units. Earlier on, we said that the definition does not necessarily consider the unit of measurement. And so once things are measured differently, we can even bring them together to understand how they relate to each other. It can be used to test and verify for significance of a relationship. And here, when you get to regression, we will explain what we mean by this particular point. And so that is also one use of the correlation. Now we have types of correlation, and these types have been categorized into these respective categories. One, we can have a simple and then a multiple correlation. Now, when we see a simple correlation, we are looking at a correlation that exists between just two variables. Simple. It is very simple because we have variable A and then we have variable B, and we are looking at the relationship between variable A and B. And that is simple correlation. In that same way, when we talk about multiple correlation, then we can have variable C and then D may be added to it. And because it is multiple, we may be interested in the relationship between one, A and B, and we can look at the relationship between A and C, and we may be interested in the relationship between B, A, and then D. That is multiple because when you pick one variable, you are looking at how that particular variable relates to multiple variables. And so that is a multiple relationship or correlation there. Now, when you come to total as against partial. Then when we have the total, mind you that whatever we see in here can be also seen here. Remember I said that simple means A and B only. Multiple means that A is related to more than one. So more than A, it is going with B, it is going with C, it can go with D. Now, when we say total relationship, we are interested in all the relationship that can be established between the variables. So if you have A, B, C, and D, total relationship simply means that we should look at A and B, we should look at A and C, then we should look at A and D. Again, we can look at B and C, then we can look at B and D, and finally we can look at C and D. So it is total. We are now looking at all the relationship that can be established among these respective variables. However, partial means that we're only interested in some and not all. Total means all the relationship. Partial will simply mean that maybe my focus is on A and C as well as C and D. That is the only relationship I'm interested in. So I'm partially considering the relationship between A and C, and then C and D, unlike the total, which will require me to look at all the relationships that can be established. And if you compare it to the first one, the simple means A and B only. The multiple means that A to B, A to C, which simply means that a multiple correlation can even be a partial correlation, as well as a simple correlation also being a partial correlation. A multiple correlation can be a total correlation. However, a simple correlation cannot be a total correlation. And so these are the dynamics. Multiple means that we are having more than one relationship established. Partial means that we are being partial, as the name suggests, we are just being selective of some of the relationships. Total means that we are looking at the holistic relationship that can be established. And then when we come to the last category, we have a linear relationship, which normally looks at the relationship on a straight line, and then the non-linear, which can be curvilinear or curvical relationship. So the linear relationship or the linear correlation is basically based on the straight line. And those who teach mathematics, when we say straight line, it means that you may have a relationship x, y, without we having any exponential in the particular function. And so normally the linear relationship becomes the simple equation that we may establish. The nonlinear mostly comes with those exponential equations, which normally comes within a curve or a curvilinear relationship. So these are the various types of correlation. Now, moving away from the types of correlation, we can now look at this, let me put it, a caution, saying that correlation does not mean the presence of cause and effect relationship. Remember, we said that correlation is just helping us to know the degree and the direction of the relationship. It is just telling us that if you bring two variables to one another, they are just going to show you the behavior of those variables. They may be moving together, they may have a strong relationship and the rest, but it doesn't really tell you the cause and the effect, which goes beyond to explain that cause and effect means if we see that the law of demand says that all things being equal, if we reduce price, the quantity of goods that consumers are likely to demand is going to be more. It doesn't necessarily tell you that if price is reduced by 5%, quantity will be increased by 20%. That is not what the law says. It just gives you the sense of how consumers are going to behave. But as to the effects when a cause is initiated, it's not really explained by correlation, which brings us to the fact that if there is a correlation between demand and supply, it does not necessarily mean that price will cause demand. Where if you reduce price by 5 cedis, you are going to see quantity increase by 20%. It doesn't give you that information. It only tells you that there is going to be a change, a marginal change, which suggests that once price is increased a little, quantity is also likely to reduce. But the magnitude, that one is another topic to discuss. So that is a caution to the explanation of correlation. Now let's look at the methods of finding our correlation. We said that we're going to start with the scatter diagram. Pearson will come in, and then Spearman will also come in. Then we will look at the correlation from covariance matrix, as well as using the regression equation to determining correlation. So let's start with the scatter diagram. For scatter diagram, it is just a normal plotting of coordinates. Now, when we say coordinates, because you are talking about two variables, let's say we have variable A and then we have variable B. The coordinates here are the values of A and B. So let's say for the first point, A is, let's say 3, B is 6. For second point, A is, let's say 4, B is 10. The coordinate here is that the first coordinate is going to have 3 as against 6. The second coordinate is going to have 4 as against 10. And that is what we mean by the coordinates. We are picking the values that is for the respective variables as against their corresponding values for the other variable. And then we just determine whether there is a relationship between the plots. So when we have our plane, we just plot the individual points or coordinates on the plane and the behavior. So for example, when we plot these particular items, let's say we consider A to be the values of on the x-axis and then B to be the values on the y-axis. Then where 3 meets, let's assume here is 3, here is 6, and then here is 4. Then we have, let's say 5, 10 in that particular order. Then it means that when we pick 3, we are going to plot 3 as against 6. And then we plot our 4 against 10. Now we just look at how, when we have others, we plot them as well. And then we look at how the behavior of that plot is looking. Now, for the flow of this plot, you can see that there is this straight line forming. And the straight line, when you study it very well, it is giving you some direction as to how the correlation is, whether it is going to be positive, negative, strong, or poor. And most importantly, it indicates to us whether there is a relationship between a given variables, that's a dependent variable on the independent variable. So normally when you plot the scatter diagram, you get certain things like this. And from here, the first figure, which is A, because of how it is flowing, you realize that if Y is increasing, X is also increasing. So if there is an increase here, there is an increase here. So once there is the same increase and increase, then we say there is a positive relationship. So there is a positive relationship because they are all going up at the same time. So they are moving in the same direction. And then when you come to the B here, you realize that if we have Y increasing, you realize that X is decreasing. Hence, they are moving in different direction or opposite direction. Hence, you are having the negative relationship. So the negative relationship is as a result of they moving in an opposite direction. The positive relationship is as a result of they moving in the same direction. And then because they are straight line, we say that this is a positive linear, negative linear, and this is also falling. As y is falling, you see that x is increasing. And so there is also negative. However, there is not a linear relationship because it is not on a straight line. And so we will call it a negative non-linear relationship. However, when you plot the coordinates and they are forming something like this circle, something like this indicate that there is no relationship because you cannot really trace the direction of this particular diagram. And so we conclude that there is no relationship in here. Any question, any clarification, confusion before we move on? Are you with me?
Yes, please.
Okay, so let's move on to the other ways of recomputing correlation coefficients by starting with Pearson's product moment correlation. So this one, you have to know the names very well. Aside the name, you should also be mindful of the assumptions that underline that particular estimation, because the only thing that is making the difference is the assumption. If you are not meeting the assumption, hence you are going to rely on another estimation. Now, Pearson's product moment correlation is basically helping us to determine our correlation coefficient. And it's having the same characteristics, the same definition as our original correlation as we discussed earlier on. However, this one normally relies on the relationship that is on a straight line or a linear association between two variables. And so if we consider the scatter plot that we did, you realize that it was mainly relying on two variables, since the relationship is basically looking at two variables that have a linear relationship. And some other assumptions, we see that there should be normality. And this one is talking about the distribution of the variables. And so the two sets of variables should be normally distributed. And I hope you remember that when we spoke about the measures of central tendency, we said that when we have a bell shape, that normality is assumed when we have the line of symmetry, when we have a symmetrical shape of the distribution of the data. And so that is normality, one. And then two, there should be a linear relationship of which I've established already. Then there should be a proper pairing, where we mean that there is a better correlation analysis when the number of items under each set of variables are equal. And so that is when we have 5 items under variable A, we should have a corresponding 5 items under variable B. That will help us to have a proper pairing. And then there shouldn't be error of measurement. And error of measurement is simply saying that we shouldn't have the measurement, the variables that we're measuring. For instance, if you're talking about the prices, we shouldn't measure the price wrongly. We should have a reliable measurement of the price so that we can rely on that output as being correct. And so these are some assumptions. I'll urge you to read more on other assumptions of this particular type of correlation coefficient. Next, we are going to look at the formula in getting our correlation coefficient. Now, originally, we have two approaches. So I'll explain this first formula, which is our R being equal to S xy over Sx sy. This is our original formula. And in this formula, this xy is considering the covariance between variable x and y. Covariance, that's the numerator, is considering the covariance between variable x and y. The denominator, we have two things multiplying. We have s of x, which the first one is the standard deviation of x. Then the second one, which is x of y, is also the standard deviation of y. This is how the formula should be first captured. The correlation coefficient, which is represented by R, is giving us S xy divided by x of x and then x of y. Now, if you want to now break it down to calculate the covariance, then the covariance is giving us this particular formula, where you have the summation of xy over n, the number of observation, minus the summation of x over n times the summation of y over n. That is giving us the covariance of x and y. Now, if you look at this formula well, it is the same thing that is captured here. Because it is covariance. The covariance means that the variance of a variable as against another variable. That is why we're calling it a covariance. Now, when you say variance, it is the variable as against itself. And last week, we were able to establish that when we find the square root of variance, we get standard deviation. We did this formula last week. And so if this is the covariance, we can get the variance of x, which is expressed as, so the variance of x is expressed as x summation of x as against x. Summation of x against x divided by n minus summation of x over n summation of x over n. Similar to what we have here. The only thing we are doing is that we are replacing this y with another x. However, when you have x multiplying x, it gives you x squared. And so it is giving us summation of x squared over n, which is the first part. And then you realize that it is x summation of x over n multiplying summation of x over n. And so we can easily bring summation of x over n all squared. And so the formula here giving us the variance. And once you get the variance, you find the standard deviation as the square root of the variance of x. And then you do same for the y, and then you are able to get. So it is a simple formula here, but before you substitute your values in here, you have to go and calculate the separate values. I'm sure by now most of you don't know what we are doing. Let's take an example to break it down. Now, taking this example, this is the second approach. So for the second approach, the R is giving us this whole formula. And so for you not to be chewing this one or not confusing yourself with so many values, you can decide to go by this. In fact, when you put these individual formulas together, there is what you get. And so you can also write this one down, and then we can look at how we can use a simple question to illustrate both formulas. And let me, when you have captured the formulas, And then we move on. Can we move on?
Yes, sir.
No.
Okay.
Yes.
Okay. So now let's look at this example. Now we having the sales of rice and oil of XYZ Company Limited within 8 months is given as follows. Now the question says that calculate and interpret the Carl Pearson's product movement correlation coefficient. So looking at the approach one, for us to get the Carl Pearson's product movement correlation coefficient, that R is given as S of XY over X of X, X of Y. And we said that the X of XY is the covariance of XY. X of X is the standard deviation. X of Y is the standard deviation as well. We also said that X of XY is equal to the summation of XY over N minus bracket open summation of X over N multiplying summation of Y over N. So it means that before we get this thing, we need to draw a table. And that table should be made up of the following headings. So obviously we have our rice. Let's assume our rice is the X, and then our oil is the Y. In this case, we are going to have X values here. We will have Y values here. Then we will need X multiplying Y because of this particular formula. Again, we will need X squared because the other part of the formula, X of X, says that we're going to have summation of X squared over N minus summation of X over N all squared. Then we will need Y squared as well because X of Y says that we're going to have summation of Y squared over N minus summation of Y over N all squared. So having these formulas in mind, it helps you to build a nice table that at the end you find the totals, and the totals are going to help you substitute into the formula to simplify the solution with ease. And so we're going to build this table together. So let's build a table together. We're having 65 here, followed by 66. Then we will follow with 67. Because of my space, you will have to complete it for me. Then the corresponding will be 67, followed by 68, 65, and then 68 again. In that particular order till you get to the last value. And so when you finish compiling that of X and Y, you just do a summation of the X, where you are adding all these values and you get a total. Then you also do same for Y, which will be the summation of Y. And then for X and Y, you are now going to multiply the 65 by 67, and the answer will be here. Then you multiply 66 by 68. And also your answer is written corresponding to it. And you do the multiplication till you get to this particular side. And so you're getting your summation of X to be equal to 544 Then you get your summation of y to be equal to 552. Then your x squared, you pick 65, you square it. You pick 66, you square it. You pick 67, you square it. Another 67 square, 68 square, 69 square, 70 square, and then 72 square. And then you sum from this point up to the last one, and it gives you a total of this. You do same for the y, 67 square, 68 square, up to the 71 square. You sum everything up, and then it also gives you this particular figure. And then x times y, 65 times 67 gives you this figure. 66 times 68 gives you this figure. Up to the end, you sum everything down, and then the total here. I hope you are following. Hello?
We are following.
Yes. So when you get the totals, when you get your totals, then you go to the formula. Here, you are now going to apply the details in the formula. I'm now going to apply the details you have in the formula. And so the first part of the formula, which is talking about the covariance, you only have to put your formula here. So the covariance x of xy is saying that summation of xy over n minus summation of x over n multiplying summation of y over n. So summation of x, y is what we have here. So we're going to have 37,560 divided by n. N is the number of observation, and we have 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8 minus, you open your bracket, you have summation of x, which is 554 over 8 multiplying 552 over 8, and you simplify. I hope you are following.
Yes, sir.
Then simplify and give me the answer. Then we go to summation, we go to x of x, which says that we need to get the variance first. And so we are going to do, remember the formula said that x of x here is going to be summation of x squared over n minus summation of x over n all squared. So that one is going to give us
Please,
summation
we
of,
can't see your screen.
oh really?
Yes, please.
A moment, please. Is it visible now?
Yes, sir.
Yes. So, Prince, your hand is up.
It was a mistake.
Okay. So when we solve the covariance of xy, what is the answer we're getting? When we simplify this part, what do we get?
I had 3.
Yes. So the answer is going to be 3. And then we go to the second part, which is now looking at the variance of x. Variance of x, we said the summation of x squared. So we just look at x squared here. Then we pick that figure, 37028 over 8 minus summation of x, 544 over 8, everything squared. The answer we get, we find the square root. So by simplifying, you realize that the covariance is going to give us 3 here. And then that of the variance of x, which is this, we are going to get 4.5. And then we find the square root of 4.5 to give us 2.123. Are you following?
Yes, please.
Then we solve for the variance of y, which is also giving us summation of y square over n minus summation of y over n, everything squared. So let's get that one also. Our summation of y square is 38132. So we're going to have 38132 over 8 minus the summation of y was 552 over 8, everything squared. Then we simplify that one also. And from there, we also look at the standard deviation of y, which is equal to the square root of the variance of y. So the answer we get, we find the square root, and we are good to go. Any answers for me? Are we working? Are you there?
Yes, sir, we are working.
You are quiet today. It's like the new year is not new year.
Please, we have 5.5 for the variance of y.
5.5.
Yes, please.
Then find the square root of that.
That will be 2.345.
Okay. Then we come to substitute it here. So now we're going to calculate our R. Remember our R, we said that S of xy over x of x, x of y. Now we know our x of xy. We know our x of xy, which is 3. We're going to have 3 divided by s of x. We had 2.1213 multiplying x of y, which is 2.345. So when you do so, you're going to have the correlation as this. And remember the interpretation that we said. We will go and look at the direction as well as the magnitude to interpret our correlation coefficient. Can we move on? So this is the first approach under the Carl-Pearson's correlation coefficient. Then we can also use the second formula, which is the one-time formula. So by this formula too, you just substitute everything inside. We're now going to have our n multiplying the summation of xy. Then we do the summation of x multiplying the summation of y. Then you come and do n again multiplying the summation of x squared minus the summation of x all squared. You do same at the y side, and it gives you the same answer. So whichever approach that, or whichever formula that you are conversant with, you just stick to that particular formula and you are good to go. And the interpretation is the same. Because of the coefficient being positive, we say there is a positive or a direct, and then the range, it falls within the strong category. So there is a strong positive relationship between the sales of rice and the sales of oil. And that is practical because normally getting to the festive seasons, you realize that when people do buy more of rice, there's likelihood that there is going to be a high purchase of oil as well, because rice goes with oil. We cook our rice with oil, we cook our chicken with oil. And so the more we buy rice, we buy oil in that particular regard. Now let's go to the other correlation, which is Spearman's rank correlation. Now, this particular correlation is used Usually when the conditions under the Pearson's correlations are not met, particularly, you remember the assumptions under the Pearson's correlation, we said that there should be a linear relationship and then there should be normality. Here, it is considered when there is no linear relationship. Again, when the set of data involved cannot be measured quantitatively or do not have a numerical value, then we can also use this particular approach to estimate. And its formula is straightforward. Now, for us not to confuse ourselves with the R and whether it is Spearman or Pearson, Spearman's correlation, we say it is R, then we add subscript S, indicating that it is correlation coefficient calculated from the Spearman's rank approach. And then the formula is that we're going to have 1 minus 6 multiplying the summation of D squared all over N minus N into brackets N squared minus 1. So this is how the formula is supposed to look like. The 1 is standing tall, and then we do everything, 1 minus everything at the left side, where we're going to multiply 6 by the summation of D squared, and then we also divide it by the N, which is the number of observation, and then into bracket N squared minus 1. So this is how the formula is. This one is a bit straightforward, but there are complex stages. So let's analyze it using the simple example first. So the following table shows the score of 10 students in science and math exams. The following table shows the scores of 10 students in the science and the math exams. Calculate the rank correlation. So just like the question goes, the question becomes specific, which of the estimation you have to do. The first one, it tells you to calculate the movement correlation coefficient. And this is saying we should calculate the rank correlation. Now, let me explain something in this particular formula, the D. The D here is looking at the deviation between the ranks. And just like the name of the correlation says, the rank means that first we should consider the various variables and then we rank them. So for instance, let's assume here is X and there is Y. We have to focus on all the values in X, rank them using either ascending order or descending order. In other words, you can rank them from the least to the highest, and then from the highest to the least. And this ranking follows what we usually do as teachers, where whenever we finish exams, we rank the student from the first position to the final student in the class in terms of positions. So that is the ranking. However, there will be a little twist here in terms of how we do the ranking. And so for this example is straightforward. So let's try and then rank the scores of the science, that is the X. Do we go ascending or descending?
Ascending.
Ascending means we should start from the least to the highest.
Yes, please.
Okay. And so the list here is which one?
22.
22. So you give 22 1, right? 22 will have the number 1. Then from 22, where do we go?
34.
34 will be 2.
34.
From 34.
41. So 40.
40 will be 3.
40.
Then 41 will be 4. From 41, where do we go to?
42.
42 will be 5. 43 will be 6. From 43, where do we go?
45.
45 will be 7. And 46. 46 is 8. From 46, where do you go? 50. 50 will be 9. So let's change this question. It's supposed to be 12 students. So 50 is 9. Then we go to 60, which is 10. 64 is 11. And then 66 is what? Wow. So you're going to do the same for. You're going to do the same for that of the math, which is the y. Danny? Danny? Hello, Danny? Yes, there is some feedback from your side.
If you can mute Danny.
Yeah,
Danny, there is a feedback from your side, so help us.
Yes, sir.
What's happening there? Are you still in your Xmas mood?
No, sir.
Okay. Now let's do the ranking for the math. Which one will have number 1, least to the highest?
12.
12.
12.
12 will have number 1, followed by
32.
30.
30.
So there's 30 here, so 2.
30.
Then from 30 we go to 32,
32.
which is 3. There's 33 here, so 4. 34 will be 5. From 5, where do you go to? From 34?
36.
36.
Yeah, 34.
Yes. 33 is 4, right?
Yes. So
Yes.
36 will be 6.
36 will be 6. From 36, where do you go to?
40.
40.
40 will be 7. Then 41 will be 8. From 41, we go to 45, right?
Yes.
9. Then 57 will take 10. 72 will be 11. Then 75 will be 12. Are you following?
Yes.
So once we are able to rank this one, we should be able to estimate our D. We should be able to estimate the D here, which is in the formula. Remember, in the formula, we have D squared. So we should be able to get our D here, and then we get our D squared. Now, the D is just talking about the difference in the ranks. D is just talking about the difference, the deviation between the ranks, which is the difference between the ranks. And by difference, we are only going to look at each pair of values, and then we subtract one from the other. Anyhow we do it, because of the square, we're going to get the same answer. So let's do x minus y, the rank of x minus the rank of y. So 10 minus 12 will give us what?
-2.
-2. So we have -2 here. And then 2 minus 3 will also give us -1. We have 3 minus 5 giving us -2. 9 minus 7 9 minus 7 is giving us a positive 2. 7 minus 9 is a negative 2. 4 minus 4 is 0. 1 minus 1, 0. You have 6 minus 2 giving us 4. 5 minus 6 giving us a negative 1. 12 minus 11 giving us a positive 1. 11 minus 8 is a positive 3. And the last one is a negative 2. Are we all following?
Please take your time.
Yes. So let's go over. Let's go over. We are saying that the D is just giving us the difference between the two ranks. So when we consider the ranks that we have done, we are just picking one from the other. So we are doing rank of X minus the rank of Y. You can also decide to go rank of Y minus rank of X. It will give you the same effect, especially where we're going to look at the R square. So if you're looking at the rank of X minus rank of Y, then we will start with 10 minus 12, and that is giving us a negative 2. We're also going to see 2 minus 3 giving us a negative 1. Are you following now?
Yes,
And
yes.
we have 3 minus 5. That is a negative 2. 9 minus 7 is a positive 2. 7 minus 9 is a negative 2. We have 4 minus 4 giving us 0. 1 minus 1, 0. Then 6 minus 2 is 4. 5 minus 6 is a negative 1. 12 minus 11 is a positive 1. 11 minus 8 is a positive 3. And then 8 minus 10 is a negative 2. So this is how we're getting our D values. For you to get the D values, we said first rank both the X and the Y, either using ascending order or descending order. Once you are done with the ranks, you move on to look at the difference in the ranks, which is the D. D is looking at the difference in the ranks. And once you are done, because the formula says that R of X is giving us 1 minus 6 multiplying the summation of D squared all over N bracket N squared minus 1. Our interest is now going to be on the D squared because the N, we know it is 12. If you count the observation, we have 12 observations. So our N is 12. All that is left for us to complete this computation is the D squared. Now we have the D, so we have to square each value under the D. And so we pick the negative 2 and then we square it. What do we get? Negative 2 square will be what?
Positive 4.
So it's going to be 4.
1.
And then 1. We also have 4.
2, 4.
4.
4.
0, 0. Then we get
16.
16. 1.
1.
9. And
9. 4.
4. Then we find the summation of the D square. We add all the values. Yes, madam.
Please, with the arrangement from this ascending order, why I was thinking we are arranging the marks according to the various position. But why are we subtracting with the numbers, rather like the labeling of the numbers from the, you understand?
So what we are saying is that for us to get the D squared, we have to first rank Abubakar.
Sorry.
So what we are saying is that before we can calculate our D square, we need to rank our raw scores. So the scores that you are getting for science, we need to rank them from either the least to the highest or the highest to the least. And that is why I was referring you to normally what we do in the report cards that we send to the students. We write an exams, they score. And so we want to rank them from the first to the least. Okay. So if you, all things being equal, assuming we were using the descending order, then it means that the highest score will receive the first position, which is 1. Now we decided to go the ascending, which means that we should give 1 to the least value. And the first person, because they are 12, is going to receive the mark or the rank 12. So we want to do that. Now, the ranking is what our focus is in, because that is what is going to give us the difference. We want to know the difference in the ranking, and that is the D. So we first have to do the ranking. And then once we do the ranking for each of them, remember, this is student A, this is student B, this is student C. So somebody may be first in mathematics, and the person will be third in science. Are you following?
Yes, sir.
And that is what you want to know. We want to understand the difference in the position these individuals are getting.
Okay.
That is why we were subtracting the rank of X, the rank of Y from the rank of X to get the difference in the person's ranks. So that is the approach you are following. Is that okay?
Yes, sir.
So once we get the difference values, we just square them to get the difference squared, and we sum the difference squared. And so we're going to add 1 to 4 to 4 to 4 to 4 to 16 to 1, 1, 9, and then 14. And so our D square will be equal to what? What will be the value of our D square? Or the summation of our D square?
48.
48. Is that correct?
Yes.
Yeah, so once you get the 48, then we come and substitute. So we're going to have 1 minus 6 times 48 divided by 12 into brackets 12 square minus 1. And that is going to give us our correlation. Again, remember that our correlation should be between -1 up to 1. And so the answer we get, if it is outside that, it means we are wrong.
So it's 0.832.
0.832.
832.
Any confirmation? Any confirmation? Hello.
We are coming, sir.
Yes, it's true.
Okay. So that is the approach here. So instead of this vertical solution, we can also have it horizontal, where we are saying that the science values are here, the math values are also in that line. Then we rank that of the X values. We do same for Y. Then we can go and do the D. We can create a column for the difference.
Please, I can't see the screen.
Is this same for everybody?
No,
I can't
it's
see.
from
You can see from here.
it's from her network.
I can see. It's a table. Oh,
Yeah. So we can do the difference here, where you are looking at the difference between the ranks. Then we do same activity. So this one was done. If you pay attention to this was done, the ranking was done descending order. So this solution used the highest to the least. However, the summation was the same. The summation of D square was the same. So irrespective of whether you are doing ascending or descending, you realize that it is going to be the same in terms of the summation of the D square. Once you pick the D square, then you just substitute it into the formula, and then you are good to go. Now the interpretation, who is helping us?
Okay, I'm trying to
Who is helping us do the interpretation? Frida.
Sir,
Help us with the interpretation.
I think there is a strong positive correlation.
Take it again. The way you started, I didn't like it. You think. As at this point, you should speak like an authority. So don't think.
There is a strong positive correlation among the variables.
So you are getting 1 out of 2.
So let me try.
Go ahead.
Very strong positive relationship.
So there is a very strong. So always bear in mind the classification as well as the magnitude. I think the direction is okay now, but the classification, you have to master it. You find a way of mastering so that you do justice to it. Okay, so this is with the rank correlation. There is a situation, you see, whenever we're doing ranking in our class, there are sometimes that's likelihood that people are ranked the same. Do you recall that? Sometimes people will be ranked the same. You get about 2 or 3 people getting the same scores.
Yes.
So when that happens, how do we do the ranking in here? That is another trouble that you have to consider. However, let's consider this illustration. I want you to try. I'm giving you a maximum of 10 minutes. Let's try this question and see. So here, our solution, the 10 contestants in the Fatia Fatankroma beauty contest were ranked by 3 judges. So already the information there, it is a rank. It has been done for you. The ranking is done for you. Okay, so you have to now find a correlation between judge 1. So let's assume here judge 1 is X, judge 2 is Y, judge 3 is, let's say, Z. What you are going to do is that you are going to find a correlation between X and Y. Then you do correlation between X and Z. Then you do correlation between Y and Z, which means that you are going to look for the D square for X and Y. Then you do d square for x and z. And you do d square for y and z. Are you following?
Yes, please.
So you are going to compute the correlation coefficient for xy. You do same for xz and then yz in 10 minutes. So I'll come back after 10 minutes and call any of you at random to take your answers. Start work. It is 1:25. You can discuss if you have issues with anything. You can let somebody lead and then you discuss. So, Juliana, you can lead the discussion. Julia said you lead the discussion, then you are off. Can I give it to somebody else?
Yes, sir.
Okay, so Rita will take over. Rita.
Sir, I beg, give it to the men, please, for now.
For now, so the men, who is ready to lead? The men, where are you? Anthony.
Say please, I object. No, I object this because women can do it better. So yeah.
No, somebody to just lead in the discussion. So you just ask how you're going about it, your answers and everything, so that you get the same answers. I want everybody to be on board. So I'll call on Prince. Prince, lead the discussion.
So please, you that they are ranked. They have been ranked already, right? Hello.
No, I don't think so.
Please, have they been
Hi.
ranked?
No.
Sir,
They are not ranked.
they have been ranked already, right?
He said they have been ranked already. That's what he said.
They have been ranked already.
But looking at the
Yes. So they have been ranked already.
please explain to
Doc,
me why has it been ranked already? Because looking at Judge 1 says 5, 10, 3, 2, 4, 9, 7, 8.
So you see,
I think their numbers, their raw score didn't come. If their raw score came, maybe 60, 50, 70, that one, that is, yes. So when you look at the numbers, it's
we will take
up to 10. So
Okay, I understand.
Please,
right.
let's read the preamble. The preamble there is saying that it has been ranked
We'll start
already.
by 3 judges here.
Okay.
The heading. The 10 contestants in Fatia Fatan Kuma Beauty contents were ranked by 3 judges as follows.
Please.
Meaning it has been ranked already.
Okay. I understand now.
First one.
So
the second one, when we take 5 from 6, what will we get?
So the first one is SY -1. Is it 6 minus 5 minus 6 or 6 minus 5?
Please, the difference in
We are
XY
taking 5 from 6, so 5 from 6.
is 1.
Okay. Then it's 1. It's 1.
So it's 1. Then the next one, we will take 8 from 5.
Negative 3.
If 3.
Negative 3.
And the next one, we will take 4 from 10.
6.
And the next one will give us negative 4. Next one will give us
4.
6.
Negative 8.
And we will take 7 ahead. So it is negative 4,
Negative 4.
negative 8, 2,
2.
8.
8. 1. 1 and then negative 1.
We take 1. Negative 1. And that is 3. Then we will square. And please, someone should help us with the squaring of the D.
Negative 2, square of negative 2 give us 4. Then square of 1 is 1. Square of negative 3 is 9. Square of 6 is 36. Square of negative 4 is 16. Square of negative 8 is 64. Then the square of 2 is 4. The square of 8 is also 64. The square of 5. Is it square of 5? Sorry, square of 1 is also 1. Then square of negative 1 is 1. Please, that's all.
Please, let's find the sum of the D square.
Okay, so sum of the D square, 4 plus 1 is 5. Then 5 plus 9 is 14. Then 14 plus 36 is 50 plus 16. That's 66, 64. 0, 130 plus 4, 134 plus 64 plus 1 plus 1. I think it's 200. I don't know if somebody can also confirm.
Yes, it's 200.
So please, did we all have 200? Now we can.
Yes, please.
The answers into them. Then we find. Okay, we will have to find for X and Z. So let's do that for X and Z.
Can you please come again?
Now we have gotten the D square, so we are finding for the D square for X and Z. So now we are looking for D square for X. So like we did for the X and Y, we will do the same thing for the X and Z.
Please, can you quote the formula for me? It looks as if I wrote the wrong one. Hello. I did. Please, someone should quote the formula for me. I'm not talking about the display, the main formula, the one something.
It's on the screen. It's on the screen.
So some of us.
Well, I wrote the wrong one. I don't see anything here. Okay. Sorry.
All one minus
So now for the
all one
second
minus.
correlation, we pick
Okay, thank you.
it will be 1 minus 6. Please, can we compare the differences we had for the X and Z? The D for X and Z. Please, can someone help us with that one? And after that, we fight for the D square.
Senior, with the X value,
with the
Z values are already there. So with X and Z, the difference is -5. 1 and 6, -5. Then 6 and 4, +2. 5 and 9, -4. 10 and 8, +2. 3 and 1, the difference is 2. 2 and 2, 0. 4 and 3, we have 1. 9 and 10, we have -1. 7 and 5, we have that's 2. Then 8 and 7, we have 1. These are the D values. Then we have to square all the D values. So D values, -5 square, that will give us 25. Then 2 square, it will give us 4. -4 square, that is 16. 2 square, that is 4. And it continues. Can I put here?
The D square, sorry, the sum of the D squares. And let's compare the answers.
So with the D squares, I said the D squares, -5 is 25. Then the 2 is 4. The -4 is 16. The 2 is 4. The 2 is 4. 0, 1. The -1 square is 1. -2 square is 4. Then 1. So we have 25, 4, 16, 4, 4, 0, 1, 1, 4, 1 as the D square for X and Y, X and Z.
And the summation is 60.
Okay, good.
We all having the same thing.
Yes. 60.
Then let's do that of the Y and Z.
Y and Z, we have the difference.
Finding for
The first one,
D
negative
of y
3.
and z,
D, yes. You have
square of y.
minus 3, 1, minus 1, minus 4, minus 6, 8, minus 1, minus 9, 1 and 2.
Can someone confirm it for us? Is it correct?
Okay, so we have with a d squared, negative 3 squared is 9. Square of 1 is 1. Square of negative 1 is 1. Square of negative 4 is 16. Square of 6 is 36. Square of 8 is 64. Square of 1 is 1. Square of negative 1 is 1. Square of negative 9 is 81. Then square of 1 is 1. Then square of 2 is 4. And yeah, the summation is 214. Yeah.
Good.
Then let's try to find the rank correlation for the first one, the second, and the third.
Mm. Oh.
Hello. Hello.
Hi.
Yeah.
Hi.
Hello. Hello.
Hi.
So, all right.
How is it going?
We are on.
Rank
Very well.
correlation the
86, 36, 360.
negative 2, negative 0.
So you are not done?
Some of us are another school. They are on it.
0.2121. Yeah.
Okay, I'm giving you extra 2 minutes to wrap up.
Yeah. This is the first one, correct? Please, the formula is 1 minus 6 sum of d squared over n bracket to n squared minus 1. So we have gotten the d squared for the first one, that is 200. The d squared for the second one, that is 60. And the d squared for the third one, that is 240. So you will substitute all what you have gotten into the formula for the first one, then you do for the second one and the third one. Please, can you share what you had for the first one? The rank correlation for
The first one,
someone share his own for us.
the first that I had a negative 0.212.
Okay, I also had the same thing.
Same here.
Then let's go to the second one. The second one I had 0.636.
Okay, I also had 0.363.
I had 0.637.
I had 0.636.
I had 637.
The third one. Why is it?
I had negative 0.
Negative 0.
I also had negative 0.296. So let's say negative 0.3.
I had this. Now let's do Who will describe the first one for us? How should we?
The first one will be a very weak inverse relationship.
Negative 0.212.
So I would describe it as very weak inverse relationship.
Very weak.
Yes, very weak inverse relationship.
What else again?
I think there's a very weak negative. It has a very weak negative correlation or relationship.
So is it inverse?
Inverse
Is
or
it
negative,
inverse
they are
or
the same.
negative?
Negative and inverse are the same.
Negative, please. I know of negative. Yeah.
Let's move to the second one.
Second, I would describe as strong positive relationship.
Okay, yes, that is. Then the third one, negative 0.29.
The third one will be weak negative relationship.
Okay. Please, any confirmation?
It's weak. Weak negative correlation.
Okay.
Hi. I think I've enjoyed your conversation for a while, but still we've not answered the question. Initially, I heard one of you asking whether it was already ranked or not. And you did justice to that one with the explanation somebody raised that it's better we read the preamble. Now, the preamble gives us a clue whether they are ranked or not. So here it says that 10 contestants in the Fatiavata and Chroma Beauty contest were ranked. And so the judges were able to rank them from first to last in that particular order. And then the question itself is asking us to use the rank correlation to determine which pair of judges have the same tastes in beauty. So the correlation coefficient that you've computed perhaps may be correct. Let's go through. So we have the judge 1, judge 2, judge 3's rank. And then we have the D square for judge 1 and 2. We have D square for judge 1 and 3. And we have D square for judge 2 and 3. And I hope you had the same D squares. The values we have.
Yes, please.
200. Then we go on to calculate the correlation for the first one. Did we get this value? Or something close to that value? Because of the decimals, we may be having different values. So
yes, different values.
So what was yours?
Add negative 0.21. Oh, it's the same 212.
Okay. And then the second one?
It's the same 0.637.
All right. So at least the understanding is there. So now we are interested in the judges with the same taste of beauty. And the meaning of the same means that their judgment should move in the same direction. And remember that when it is positive, it means that they are moving in the same direction. When the correlation coefficient is positive, it means they are moving in the same direction. So by the answers we have, the 1 and 2 is negative, and then 2 and 3 is also negative. So it is only the relationship between 1 and 3 that is positive. And once it is positive, it means that our conclusion is that we are going to conclude that judge number 1 and judge number 3 have the same taste of beauty. And the reason is that their correlation coefficient is positive. Are you following?
Yep.
Yes.
Now, in terms of investment, which of the three, assuming these are three different investments that we want to combine two in our portfolio, in that case, because it is investment, it is preferred that we go for a negative correlation. And so it depends on the motive of the question. If the question is talking about investment, then we would have chosen the negative one. In fact, a negative with the strongest magnitude would have been chosen. In this case, we are not doing investment. We are doing the same taste for beauty. That is why we are choosing positive. So I'm just drawing your attention that the question may not necessarily come in the same food, but you have to read the question to understand the intention of the question before your answer. And note that if it is investment, then we are going to go with the most negative. If it is like this particular question, how the direction was given in the main question, then it means that we are going with the highest positive. And so you have to take note of that. However, I must say that you did well. I was following your discussion anyway and how you went through. I didn't know, I'd even forgotten that you are teachers already. And so the way you were handling issues, that was a plus. Now, as I was saying, when we have a tied rank, sometimes when we're moving through, we may be faced with 2 or 3 having the same rank. In that case, we extend the formula a little and include this particular side of the formula. So you realize that there is an extension here where we are seeing this part as new in the formula, and it is coming as a result of the tie. Hold on, give me a minute. Yes, so whenever we have a tie, we then use the extended formula. Remember, the first one was just R of S giving a summation of 1 minus, we had 1 minus summation of 6 times summation of D over N minus 1. Now we're having the same summation of D here. We have our 6 here. However, we are having a summation of M cubed minus M all over 12 as part of it. And that part is showing where there is a tie. And so the M is talking about the number of ties that we have in there. And let me use this example to quickly explain what we mean by the tie. And when we have a tie, how we should go about the tie. Just briefly, then we move on to another thing. Now, when we have this Let's do the ranking from any other. So let's rank X, let's rank Y. Let's say we are ranking from descending order. So the least one first. How do you go about it? Which one is it?
Descending or ascending?
Let's do descending. So let's do it this way. We have X, we have Y, 50, 55, 65, 50, 55, 60, 50, 65, 70, and 75. And we have 1, 1, 1, 5, 1, 2, 5, 1, 4, 3, 1, 1, 5, 1, 30, 1, 20, 1, 1, 5, 1, 60. So let's rank it ascending. Now we have, let's go by any approach, whichever way that you're okay. I'm only showing you how the tie rank will be done. So rank of X, then we do rank of Y. Then we find the difference. Then we do the difference square. So let's start with the rank of X. Let's assume we are moving descending order from least to highest. Descending will be highest to the least. Highest to the least. So we will have 75 as the highest. So this will go for 1, right? And then 70 will be 2, followed by 65. So 65, you have 1 here, you have another 1 here. Are you following?
Yeah.
Technically, one of the 65 should be 3, and then another should be 4. But because they are the same, here what we do is that we are going to add the 3 to the 4 to give us 7 and divide it by 2 to give us 3.5. So we're going to have 3.5 here and then 3.5 also here. And this is so because the 3.5, we are taking it from the number of positions. So this should have been the 3rd and this should have been the 4th. But because they are the same values, we have to ascribe the same value for it. In our report, we would have written 3 here and 3 here. Is that not the case?
Yeah.
But here we are going to add the positions and then divide it by 2. So one is occupying the 3rd position, the other is occupying the 4th position. We add the 3 and the 4 and divide it by 2 and get 3.5. And then we give each of them 3.5. And we move to the next. The next is supposed to be the 5th position. Now the 5th position will go for 60. So 60 will be 5th position. And then from 5th position, we go to the 6th position, which is 55. So 55 is going to be number 6, and then number 7. So number 6 and 7. So let me do it this way. You let me do it like we did for the first one, so that we don't get confused. So this 50, the 60 is going to be, the 60 is going to be 5, and then we're going to have the 55. The 55 is going to occupy 6 and 7. So 6 and 7, we add the 6 to the 7, we get 13. 13 divided by 2, we get 6.5. So this is going to give us 6.5, and this is also 6.5. So from there, we are moving to the 9. We are moving from 7 to 8. So this is 8, this is 9, and this is 10. So we're going to add 8 plus 9 plus 10 and divide it by 3. And that is 9. So 50 is going to be 9 50 is 9, and the last 50 is also what? 9. So we're going to have 9 here. We have 6.5. We have 3.5. Another 9. 6.5. 5. 9. 3.5. 2 and 1. I hope you followed.
Yes.
A bit confusing, but it's when you practice for the second time, you'll be able to go by it. I hope that is okay. The confusion is not even here because let's do the same approach for the Y. Let's go the same approach for Y and see. Let's go the same approach for Y and see how we'll go about that. So for Y, we are going to have 160 to be 1, followed by 140 to be 2. Are you following?
Yes.
Then from 140, we go to 130 to be 3. Then 125 will be 4. 120 will be 5. Then 115 is supposed to be 6, 7, and 8. So we're going to add 6 to 7 to 6 and divide it by 3. That is going to give us 7. So we will give this one 7. This will also have 7. And this will also have 7. The next one is supposed to be 9 and 10. So we add 9 to 10 and divide it by 2. And that is going to give us 9.5 and 9.5. So we're going to have 9.5 here, followed by 9.5, followed by 7, get 4, 2, 7, 3, 5, 7, and 1. So this is how the rank is being done. Then we can proceed to get our D and the D square. So let's complete the D and then the D square. The D, we are going to have negative 0.5 here. Then we get negative 3. Is that right?
Yes.
Yes.
Then this one will be negative 2.5. Going to have 5 here, followed by 3.5. Is it 4.5 or 3.5? 4.5.
4.5.
Get negative 2. You get 6. It's negative 1.5. Get 5 and 0.
Negative 5. Negative 5, not 5.
Negative 5. Thank you. Negative 5. Then we square it. So 0.5 square is going to give us 0.25. This is giving us 9.
9.
Then we're going to have 2.5 square, giving us what?
6.25.
6.25. Then we will have 25.
25.
Then we will have 22.25. Is that right?
It is 20.
No, sir. It's 4.25.
25. Okay. Then 1.5 square.
2.25.
2.25. 25 and then 0. Then we do our summation of d squared.
One oh three.
103. Is that right?
I had 128.
128. We need confirmation.
The sum at the last bottom. Let me see. Okay, plus 25.
I also got 128.
Yes.
128. So
yes, it's 128.
128 is standing.
Yeah.
So once we have our d to be 128, then we can go ahead and then compute using the formula. So let's clean this one. And then we get a space. Yes. So here we're now going to apply the formula. We're saying that the R of S is giving us 1 minus 6 multiplying the summation of d squared plus m cubed minus m over 12 all over n into bracket n squared minus 1. So this becomes your formula. Now, in this formula, the m here is just looking at the number of ties that we have. So we can have, for this question, we have the tie for 50. 50 we have, so the first m, which is the first m. How many 50s do we have? We have 1, 2, and 3. So it means that our first m is 3. Okay, your hand is up.
Sir, please, can we look at the d squared again? The
What did
ED
you
squared
get?
summation.
What did you get?
I had 13.32.
134. These are d square ones. So the answers you gave were all wrong. So let's cross check.
Okay.
Our d square will be 134. Let's cross check and then correct ourselves. So let's go back to, can we move on?
Yes, please.
Okay. So let's go back to what we were doing. Now, the M here talks about the number of ties that we have, or the number of pairs that are the same. So we have 50 being the first M. And the 50, we check how many numbers of 50 do we have in that particular rank, and they were 3. So our first M, which is M1, is equal to 3. Then we go to the same X. We realize that the 55 2 were 2. And so in that case, M2 is equal to 2, because we had 2 of the 55s. Then M3, again, we saw a tie with 65 and 65. So M3 is also 2, which means that the M depends on the number of items that are making the tie. So if we have 2 students scoring the same mark, that is the first M, which is 2. If you have 3 students scoring the same mark, that is the next M, which is 3. If it happens that 4 students are scoring the same mark, it means that that M is going to be 4. Are you following? So the value of M depends on the individuals who are making the same score in the same category of rank. And then again, when we came to Y, we saw another tie. So M4, the 100, 110 was 2. So M4 is equal to 2. And then M5 was with 115. So 115, you had 1, 2, and 3, meaning that M5 is also 3, which simply means that our final answer, which is S of I, is going to be equal to 1 minus, then we expand this particular one because there was a summation here. And so we're now going to expand. Once we have the summation sign here, we're going to expand it based on the number of M's that we have. The final answer is going to be 6. Now we open bracket, the summation of D, which is 134. So we're going to have 134 plus this plus here, the plus we have here, captured. And then we'll introduce our first M, which is 3 square, 3 to the power 3 minus 3 over 12. Then plus the second M, which is 2 to the power 3 minus 2 over 12. The third one is 2 to the power 3 minus 2 over 12. Then we go to the fourth one, which is another 2 to the power 3 minus 2 over 12. Then the final one is, so we have to bring our plus here, then the plus here. Then the final one is 3 to the power 3 minus 3 over 12. Then everything here divided by the number of observations, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 into bracket 10 square minus 1. And that is how the expansion is going to be. So you have to always, as you are getting the pair, note that each pair is corresponding to a particular M. And once you get those individual M's, the first one was 3. The first M was 3 because you had 3 values getting you that pair. The second one was 2 because 2 values get you that pair. And then you go through that and you get the final answer simplified as such. So when there is tie, there are 2 extra steps that you add. The first one is how you are going to do the ranking. And the ranking means that you should do the continuous counting. However, when 2 values are the same, you just add their corresponding continuous values and divide it by the number of values getting you the tie. And then you get those values. Then you have to also get the values of M as you are going along with your rank. And once you have the M values, you substitute and you are good to go. This is a bit challenging. So as you did the discussion, I'm encouraging you that when you get the slides, you can come back to this session and do more discussions here as a class. Now let's move to the coefficient of determination. I told you that this one simply explains the proportion of a total variation that one variable is going to have on the other. So when we have x, y as variables, if we consider x to be the independent variable, and then y to be the dependent variable, it means that the value of y depends on the value of x. Your amount of money you spent during the Xmas was dependent on the salary you received during the Xmas break. So even with that one, people were thinking about the 60 days January that was ahead. So your spending in December was basically you trying to consider how you are going to survive in January. Because I was told your salary came around 16th of December. So by the time you end December, the salary is gone. And you surviving the entire January becomes a problem. So dependent variable and the independent variable. Now, the coefficient of determination is simply looking at how the independent variable, the strength of the independent variable in explaining the dependent variable. That is just the strength. And it also ranges from 0 to 1. And it is written as R squared. Remember, we said R is equal to correlation. And so whenever we square our correlation, we get our coefficient of determination, as simple as that. So when we calculate our correlation, the answer we get, we find the square of that answer. And that is our coefficient of determination. So for instance, if our R is equal to 0.922, then it means that our coefficient of determination, which is the R square, is going to be equal to 0.85. Meaning you just square the 0.922 and then you are able to get an answer. And the interpretation is that 85%, the 0.85 that you see there, the 85% of the total changes that you see in Y can be explained or is attributed by the changes that you are getting in X. And that is what it does. And then we can also see that the 15% is also explained or triggered by other factors, but not that particular factor of interest. So there is just the coefficient of determination. The computation is straightforward. We just have to square the correlation coefficient and we have our coefficient of determination. And we should also bear in mind that the range of the coefficient of determination is starting from 0 up to a maximum of 1. 0 up to a maximum of 1. Then we can also illustrate how to calculate our correlation, basically using the covariance matrix. And this one, we have an illustration here to show. So if me now want to invest, now this question is talking about investment. If me now want to invest, and she is considering any two of the following investment opportunities, A, B, and C, with a correlation matrix of this particular matrix, then we have to construct a correlation matrix and advise her on the best combination. Now, this is a matrix, and so let's see how the matrix works. And the matrix is just a covariance matrix. Earlier on, I said that correlation is equal to x, xy over x of x, s of y. And it is the same formula that we are going to use in calculating our correlation. This time around, we are going to do correlation A and B. We will do correlation A and C, and we will do correlation B and C, not XY. The XY is just explaining. Then from this formula, we say that the numerator is looking at the covariance of X and Y. So where, if you come to the matrix, where A is meeting B, which is the -8, is looking at the covariance of A and B, which is -8. S, A, and C is where A and C are meeting, because already they are covariance matrix. So where A and C are meeting, which is -1, is also considering the covariance between A and C. The same way, we can also have the covariance between B and C. And what will be the answer? Covariance B and C.
It is the third one, the 3.
-9.
Covariance between B and C will be what?
B and C is 3.
B and C.
B
is
and
3.
C.
So
Yes,
where
3.
B and C intersect is 3. Okay. Now,
Sir,
after
please,
getting
can you
the
go over?
Please, so where from the value, so the
I like this one. When you are getting lost, you let's draw my attention, then we come back. Okay. So we are going back to the correlation. It is just used to estimate the correlation using this formula. And from this formula, we mentioned that the numerator here is talking about the covariance between X and Y. Do you get this side?
Yes.
Yes, sir.
How do we read the covariance from the matrix? Already the matrix is a covariance matrix. And so if you want to get the covariance between A and B, we are saying that you just have to look at where A intersects with B. And that is the covariance of A and B. Is that cool? And so where A and B are intersecting, the value is -8. And that is the covariance between A and B. Then we will go ahead to look for covariance between A and C. Where do they intersect, A and C? What's the value of where A and C intersect?
It's -1.
Please, I'm talking to my
-1.
ladies. Don't disturb us.
Sorry.
Yes, a -1.
So we have -1. And then we go for the covariance between B and C. What do you get? You get 3. So there is more of look and see. And that is as a result of the matrix itself. The matrix is a covariance matrix. So the values in there are covariances. Is that okay? Then we also said that we can also have the covariance of X and X, which we don't call the covariance because it's just one variable. And so we call this one the variance of X. The variance of X, I'm writing it this way because we are looking at where X is meeting X. And so if you want to calculate the variance of A, you are now going to look at where A and A are meeting, and that is what? 29. Are you following?
The first one is 29.
That's the variance. That's the variance of A. You look at where A meets A. And then when you want to find the standard deviation of A, you do the variance of A, square root of variance of A. We are picking this idea from the early concept that we did, the Pearson's moment correlation that we did, if you recall. That is how we were able to get the standard deviation. We said the standard deviation is the square root of the variance. So when we pick the variance of A is where A and A is meeting, which is the 29. So if you want to calculate the standard deviation of A, you only find the square root of the variance. Then we do same for the variance of B. That is where B and B meet. And the value is 6. And so we can find the standard deviation of B also to be equal to the square root of what? 6. Then we go and calculate the variance of C, which is giving us 2. The standard deviation of C is giving us what? Square root of what? 2. In this case, when we come back to calculate, that is the simplified one that we have here. And so when we come back to calculate, let's do the calculations here. When we want to calculate the correlation between now we saw that the covariance of A and B was -8, covariance of A and C -1, covariance of B and C was 3. Then we have the standard deviation of A to be the square root of 29, standard deviation of B, square root of 6, standard deviation of C was square root of 2. After doing it this way, then we can say that the correlation between A and B is giving us SAB over SA multiplying S of B. The covariance between A and B divided by the standard deviation of A multiplying the standard deviation of B. Then we come here and pick the values. Covariance between A and B is -8 divided by the standard deviation of A is square root of 29 multiplying the standard deviation of B, which is the square root of 6. Then we simplify. Then we can also do the correlation between A and C to be equal to the covariance of A and C over standard deviation of A multiplying standard deviation of C, which we are going to get -1 over the square root of 29 multiplying the square root of 2. I hope you are following.
Yes, sir.
So let's work and give me the answer. The last one will be correlation B and C being given as covariance of AC over standard deviation BC over standard deviation of B, standard deviation of C, which we are going to get 3 divided by the square root of 6 multiplying the square root of 2. So let's solve the 3.
The first one is -0.606.
-0.60.
6.
Hello. 606.
Yes, please.
Okay.
Let me see.
The second one is
negative 0.1131.
Negative 0.131.
Yes. The third one is 0.866.
0.866.
Yes,
Okay,
please.
so because you are going to construct a matrix, we're going to have it this way. The 0.606 is what you are seeing here. That's a correlation between A and B. And then the positive one, which is A's, you said it is 866. You're also having the 87 here. And then the negative 0.131, you're also having the negative 0.13 here. So A and B is this, A and C is here, and then B and C is also here. Now the same thing is duplicated half here to show you the same thing. So you have AB the same value, AC the same value as this, and then the BC. So you have B here against C, also having the same value as this. Then the diagonals is 111 because when you find a correlation of the same, let me illustrate it to you. So when you find SAA over SA times SA, going to get the same thing. SAA from the matrix was 29 divided by square root of 29 times square root of 29 will give you 1. So when you find the variance or the correlation of A and A, you are going to get 1. If you find the correlation of B and B, it's going to be 1, and then the correlation of C and C is also going to be 1. So there is the matrix above, or whatever you sort. Now the conclusion here is that because we are interested in the negatives, we are going to compare which of them was negative. So R, A, and B was equal to negative 0.606. R, A, and C was also equal to negative 0.131. So we have negative 2 in it. For investment, we don't normally advise that you invest with assets with the same correlation. So once it is positive, we don't consider that one. We are interested in the negatives. Unlike the beauty question, I was using that one to explain. So we are interested in the negative. Now we have 2 negatives, and that is where the magnitude comes in. We are going to select the highest negative, or the negative with the highest number. And so that is how we're going to go about it. In this case, 0.606 is greater than 0.131. So we are going to consider the combination of A and B as compared to A and C as our final answer. Is that okay?
Yes, sir.
All right. Let's end this portion here and then break for some 5 to 10 minutes. Then we start with the second one. So I'm giving you a 10 minutes break. When we are done, we start with the calculus aspects. We do some few, we do like 1 hour, then we close. So we will continue. We are going to resume at exactly 2:50. So let's bear in mind. We shouldn't go far. You can have some discussions on the platform, but we shouldn't go far. Yeah, so yeah, back. Hello.
Hi.
Hello, sir.
Yes, so let's inform those who dropped that we are back. Let's try and do something little and then we continue from next week. I was earlier on suggesting that we find 1 or 2 evenings within the course of the week so that we can complete it. Because coming weekend, I may not be available. So we'll look at that. Can you hear me?
Yes, sir.
Yes, please.
So I'm setting back my screen so that we kickstart that of the differentiation. So the course rep, please, after the class, discuss with your people the days that are favorable. We arrange and then we do that.
Okay, sir.
Yes, so for this particular topic, we're going to look at how we can explain the meaning of differentiation. And then we look at some basic rules of differentiation, particularly the sum rule, the constant rule, product rule, quotient rule. Then we also look at the first and then the second derivative, where we're going to look at the application basically. And then we will define integration as well. And then look at the maximum minimum application in business, where we going to look at marginal concept relationship among total marginal and the average concepts. So it is a packed topic, but we're going to break it down to make it simple. So let's look at differentiation. Now, for those of you who are teaching mathematics, you know the approach in estimating the equation of a line, where we said that we look at the change in y or the gradient of a line. We say it is change in y over change in x, where we can expand it to do y2 minus y1 over x2 minus x1. This particular sign we have here is talking about the change that is happening to y as a result of a constant or a simultaneous change in x. And this change, as we have here, is the same as this symbol that we have here, which is also talking about the differential, which also looks at the change in y with respect to x. And so when you write the dy over the dx, it is talking about the differential of y as a result of instantaneous change in x. And it is the same as the change in y over change in x. So we can call it interchangeably. However, we usually use this one, which is the divide dx, especially when we're talking about equations and we want to find the differential. And then we use this delta sign when we are normally talking about absolute values. And so it is communicating the same thing. However, the first one is looking at equations, and then the second one down the slide is looking at absolute values. And so we always look at the differential of a given function so that we change that function from the total. For instance, we can change total revenue function to marginal revenue by just looking at how we can differentiate the total revenue function. We can also do same for total cost. When we find the differential of a total cost function, it gives us the marginal cost function in that particular order. So it's only helping us to know how we can find the changes that is happening to a particular variable y as a result of instantaneous change or a simultaneous change that is also occurring in a variable called x. So for us to know this differential thing, we have to understand the rules that governs the differential application. And the first rule is the power rule, constant rule, sum rule, and maybe we will focus on the first three. We will just focus on the power rule, constant rule, and then the product, maybe product rule or sum rule. And then we can move on to the application to solving the complex business problems. And so let's start with the power rule. Now, the power rule basically says that when we have a given function as this, y is equal to a multiplying x to the power n. Now, this function is giving us y to be the dependent variable. The y is dependent on the x. So, however, the value of x is going to determine the value of y. And so y depends on x. And then this x is also called the independent variable. So x is our independent variable, y is our dependent variable. And then a in this given function is the coefficient of the independent variable. A is the coefficient of the independent variable. And then we have the n being the exponent or the power of the independent variable. Because the independent variable predicts the dependent variable, the focus is on the independent variable. In this case, when we want to find the differential of such term in a given function, we write the differential as dy dx, giving us we multiplying the a, which is the coefficient, by the n, which is the power. And then we bring our x value, and then we reduce the power by 1. So that is the first rule of differentiation, the power rule. It says that whenever we want to find the differential of a given function, dy dx, is going to be when we multiply the coefficient of the independent variable by the power of the independent variable, and we reduce the power by 1. So for example, when we have y is equal to 3x power 4, dy dx is only saying that we should multiply the 3 by 4, and then we bring our x, and then we reduce 4 by 1, which in effect, 3 by 4 is going to give us 12x to the power 3. So that is the dy dx, or the differential of that particular term. I hope you are following. Hello.
So we are
We are following.
following.
Okay. If you are following, and for me to be convinced that you are following, let's try this example. Who is going to differentiate y is equal to 1 over 3 x to the power 3 for me?
1 over 3.
1 over 3 x to the power 3. Any idea? We follow the same procedure. We multiply the coefficients by the power and reduce the power by 1.
Please, I had x squared.
X squared. And so dy dx is going to be equal to 1 over 3 times 3. Then we have x 3 minus 2, 1. This will cancel, so we're going to have x to the power 2. Let's try another example. Y is equal to 2x to the power 4. 2x to the power 4.
It's 8 raised to the power 3.
8 raised to the power 3. So dy dx is equal to 8 raised to the power 3. My ladies, are we following?
Yes, we are following.
Okay. So that is the power rule. That's the power rule. So that is the basic rule that we need to understand. Then we go to a constant rule. Now, when we said y is equal to ax to the power n, when we have a c here, let's say we have a c here, we call this one term, and there is another term. However, the term c or any term without the x variable means that that particular term is referred to a constant. And so whenever we want to differentiate a constant, for example, when we have any value, that constant becomes 0. So dy dx of any constant is equal to 0. That is what the rule says. We will look at an example and then we will connect it very soon. Then the same preamble, when we have y is equal to a x to the power n plus c. Because there is one term and there is another, the sum rule says that anytime we have a given function or equation that is separated by the addition sign or the subtraction sign, then we need to apply the sum rule in differentiating it. Anytime we have a given function that is separated by the addition or the subtraction rule sign, then we have to apply the sum rule. However, the sum rule basically means that we should go back to apply the power rule and the constant rule. However, we should focus on differentiating its term after term. For example, when we have y is equal to 3x to the power 4 plus 2x to the power 3 minus 6x to the power 2. We can apply the sum rule by looking at differentiating each term after term. And so we will pick this first one and assume that it is y is equal to 3x to the power 4. And we apply the power rule. Then we come and apply 1, y is equal to 2x to the power 3. We do same. We do y is equal to negative 6x to the power 2 and differentiate them one after the other. In this case, dy dx is going to be, when you focus on the 3x to the power 4 and differentiate, what do you get? You multiply the 3 by 4
X.
and you,
X.
what do you get?
X.
3x to the
It's
power 4. What do we get?
12 raised the power x cube.
12x raised to the power 3.
To the power 3.
Is it understandable? Okay. Then we
No,
also...
sir. Please let's go over, sir.
Okay. Okay. So what you are saying is that you are going to focus on it one after the other. So y is equal to 3x to the power 4. By the power rule, we are going to multiply the 3 by 4. And that is what we have here as 12. And then we reduce the power by 1. And so 4 minus 1 will give us what? 3. Is that okay now?
Yes, please.
Yes. Then we move on to the 2x to the power 3. We follow the same power rule. We multiply the 2 by the 3 to give us 6. And then we reduce the power by 1, which will be what? 2. We do the same thing for the minus 6 by 12. By 2 will give us 12. And then we reduce the exponent by 1. So our final answer for that function becomes this particular answer. I hope you are following.
Yes.
So these are the first 3 rules that I want us to stick to. The remaining 2, I'll hold it for now. I'll hold it for now because of time. So let's try these examples. Let's try and differentiate these examples. I want you to take about 10 minutes, discuss and then differentiate. Remember, we said that when you differentiate a constant, the answer is what? 0. So this time I want Rita to coordinate so that you differentiate these ones based on the rules that we've gone through. So the next 10 minutes, discuss how you're going to differentiate these following function based on the 3 rules that we've looked at. Rita, over. Yes, you are doing all this. So lead the discussion and then let me see how.
All right. All right. Hi. So let's all come on board and solve the first one. So who is done with the first one?
First one I had
Please, the floor is open.
3x
You
squared.
had what?
3x squared. Minus
Plus 12x.
Plus what? 12x.
Yeah.
plus 12x minus 2.
Plus
Please, I'm listening. Please, any confirmation?
I got 12x square.
I had
Minus
3x squared plus 12x minus 15. 15.
two answers now. 3x squared plus 12x minus 15, and then 3x squared plus 12x squared minus 15.
Okay. I also have 3x squared plus 12x minus 15.
Then I also had 3x squared plus 12x plus 15. Please, the second one.
The second one is 12 minus 4x.
Twelve minus 4x.
So
Please come again.
12 minus 4x.
Rita, the first one, let me bring you back a little.
Okay.
I got 3x squared plus 12x squared minus 15x minus 3, x exponent negative 3.
Hey, wait.
Oh.
With the exponent 4, we assume that the x has a power of 1.
Yes.
Yes.
X has a exponent of 1. So 1 times 15, that gives us the negative 15. So 4 minus 1, giving us 4 minus 1. So not negative 3, positive 3. X3. Negative 15.
Square from the 4.
So what, you are confusing me.
Where do you get the 4 from?
So if it's 1 and you are subtracting another 1 from it, won't it be 0?
It will be 0.
So where from 4?
Okay. Let's move on.
Right. Please, the second one, any confirmation?
The second one is
I
12
also
minus
got
4x.
12 minus 4x.
Please, what about the 5,000?
What about 5,000?
What about the 5,000?
Sir said if
In
you
that
decrease the constants, you get 0.
Yeah, thank you.
So the
Oh,
5,000
okay.
is constant.
Yeah.
Okay, the third one, number 3.
3x squared minus 20x.
So 3x squared minus 20x.
So the 3,000 is also constant.
Yes.
Please, any different answer?
No, the same answer.
All right, the fourth one. Question 4.
I had 12
4x squared.
x squared plus 12.
Please, we can't hear you.
12x squared plus 12.
Okay. So 6 is constant.
Yes.
Please, any confirmation or any different answer?
It's fine.
Please, we all got 12x squared plus 12.
Yes, done.
Okay. Question 5.
We have 14.4x plus 3.3.
Yes.
So 14.4x plus 3.3. Yeah.
Yes. Please, any different answer? Please, you all get 14.4x plus 3.3. Hello.
I had the same thing.
Yes.
All right. Then the last one.
So 10x minus 8x minus 12.
Not
Please take your time.
sorry,
Say
not
15.
15 rather.
Take your time.
15x
Yeah.
minus 8x.
Yeah.
Yeah,
15x squared
minus
or x?
12.
15x squared.
15x squared
Yeah.
X squared
minus
plus
8x minus 12.
8x. Sorry, minus 8x minus 12.
Minus 12.
All right. 15x squared minus 8x
Minus 12.
12. Please, any answer? Any different answer? All right. Oh, please, we are done.
Okay. So I'm glad that we have been able to differentiate them. So the only concern I have, what's the answer for the third one?
Third one.
Constant is negative.
3x squared
So 3x squared
minus
Okay.
20x
X squared minus 20. X squared
minus
minus
20x.
20x.
3x squared minus 20x. And this one, the second one, you have 12 minus 4x.
4x.
Okay. The fourth one, 12x squared plus 12. And then, okay, so that is it. Now we will skip these two, which is the product rule, and then the quotient rule. And we will start looking at finding the turning point of a curve. By this, we are trying to look at how we can find maximization and then minimization. Normally, when you take organizations, you realize that the two major objectives of every organization is that they want to maximize their profit. And then at the same time, because achieving that requires them to minimize their costs. When you're able to control your costs, then you are likely to maximize your profit. And so we want to look at how to get the maximum profit and then how to get the minimum costs. And we follow these particular steps. The first step says that we should find the first derivative. So let's write these steps down. We are to find the first derivative. And then point number two. Point number two should be like this. Equate. You should equate the first derivative to 0 and solve for the values. Should equate the first derivative to 0 and solve for the value. So that is point number. The first step is that we should find the first derivative. The first derivative simply means that we should find dy dx. And when we get dy dx, we should equate dy dx to 0, and then we solve for the values of x. And then the third one says that we should find the second derivative. That is, we should do the first derivative that we had, the answer we had for the first derivative. We should differentiate it again. And then when we do that, we are going to call the second derivative as d square y over dx squared. And then that is the second derivative. And then we substitute. So let's add a little more to this third point and substitute the values of x into the second derivative. So the third point says that we should find the second derivative and then substitute the values of x that we solved in point number 2, in step number 2. We do that and substitute them into the second derivative. Now, the 4 is an interpretation. The 4 is an interpretation. If the result, after finding the second derivative and substitute, if the result is positive, it is the minimum turning point. And then if the result is negative, it also means that we have a maximum turning point. So these are the 4 steps that you go through to know the turning point of a curve. And let's take this example to go through the steps. Find the turning point of the following equation. So we have y is equal to x to the power 3 plus 6x squared minus 15x. It says that we should find the first derivative. So let's find the first derivative. What will be the dy dx? If you have y to be equal to x cubed plus 6x squared minus 15x, what will be the differentiation? When we find dy dx, what do we get?
So we have
3x squared plus 12x. Is that all?
But the other one becomes the first.
minus 15.
Minus 15.
Minus
So the first derivative is 3x squared plus 12x minus 15. Then we go to step number 2. Step number 2 says that for us to get the minimum or the maximum, we have to equate dy dx to 0. In that case, we are going to get 3x squared plus 12x minus 15 is equal to 0. And then we solve for the values of x. Now, looking at this equation, it is a simultaneous, it's not a simultaneous, it's a quadratic equation. This becomes a quadratic equation. And at this level, we are not interested in the almighty formula. We are not interested in the factorization approach. Just pick your calculator. You go to the function side, and then you pick your equation. Then from there, you pick your quadratic equation, you enter, and you have the values of x. So those with calculator help us get the values so that we move faster. So we're going to have x1 to be equal to and x2 to be equal to. So two values of x.
Please, I need to learn how.
So we have to learn how to use the calculator.
Sir,
I'm listening.
please, the x1 is equal to 1 and the x2 is equal to -5.
Any confirmation?
Yes, please, it's correct.
Okay. So
I thought
nobody should ask me how we got the 1 and 5.
I got it. I got it.
The answer was said on the page. He said that we should learn how to use the calculator. So from here, we move to the third step. We are now done with step number 1 and 2. We go to the third step, which says that we should find the second derivative. Now, if you have dy dx to be equal to 3x squared plus 12x minus 15, then the square y over the x squared means that we are differentiating these functions again. So when we differentiate 3x squared plus 12x minus 15, what will be our answer? 3x squared plus 12x minus 15. What will be our answer?
6x plus 12.
We all agree to that.
6x plus 12.
6x plus 12. Okay. Then it says that once we get the second derivative, we should substitute the values of x into the second derivative. So we go like this. If x is equal to 1, then it means that the second derivative will be equal to 6 multiplying 1 plus 12. And that will be 18, right? And then if x is equal to -5, it means that our second derivative is now going to be equal to 6 multiplying -5 plus 12. And what do we get? -18. So it means that this particular question, we are having two curves. One is a minimum turning, and the other is showing a maximum turn. Because the stage 4 states that if our answer is positive, it means that we are having a minimum turning point. If our answer is negative, it means that we are having a maximum turning point. Is everything clear as at this point?
Yes, sir. Very, very slow.
I like the answer. Now let's look at a business application here. Okay, let's try this once and see. Let's try this second one and see. Or when you find time, you do the trials. So I'll give you the slide so that you solve the trials. Whenever there is an issue, then you contact me for explanation. Now let's look at this business application question. When we are done with this question, we can close for the day. This is how to make this is a past question anyway. Let me add to it. This was question 3A or so. So let's look at how we can solve it. Now, Mami Akato is a member of UCC Business Women Association.
Please, we can't see your screen.
Oh, sorry about that. Sorry. Is it visible now?
Yes, sir.
Yes.
Yes. So this is application question. Mami Akato is a member of UCC Business Women Association. The business advisor of the association presented a report after a survey of the business performance. The business venture of Mami Akato has a total average revenue function of 14 minus X plus 3,400 over X, and the total average cost of X squared plus 15X plus 3,200 over X. Determine the number of units of production X that may maximize profits and revenue. So this is a typical exams question. In fact, it's a past question. So unfortunately, it may not surface again. But it is going to guide you on how to prepare for your exams. Now, whenever we have such a question, we are interested in the main part of the question. Determine the number of units of production X that may maximize profits. And just now we looked at, Mark, can you please mute yourself? Mark or Anthony? Mark.
It's Mark.
Ofosu, yes. Just now we looked at the steps that we go through.
It's Mark.
You've done that, so let's continue. We looked at the steps that we go through to get the turning point. And remember, the fourth point says that when our turning point is showing a negative answer, it means that is the minimum that is the maximum turning point. If the turning point is negative, it means that is the maximum turning point. And that is what this question is interested. It's looking at profit maximization. Now, for such question, we have two approaches to solving this question. Now, the maximization can be gotten through a condition. First, we talk about profit being maximized when our marginal cost is equal to our marginal revenue. There is one condition. And then again, we can use the 4 steps that we've gone through to also estimate the profit maximization, the values or the production units that will help us to maximize our profits. However, this question is a bit tricky because it didn't give us the total revenue. It didn't give us the total cost. However, it gave us the total average revenue and then the total average cost, which means that for us to get our profits, the whole idea is that our profits is equal to total revenue minus total cost, true or false. You only get profits after subtracting your total cost from your total revenue. And this question didn't give us any of these two. However, we have information that can help us to estimate our total revenue as well as our total cost. So we have to know the relationship that exists between average revenue, total revenue, and marginal revenue. Now, when we have average revenue, we can get our total revenue from the average revenue by saying that average revenue times quantity will give us total revenue. And that is what we did in a course way back. Average revenue. For example, when we have, let's say, a product that you are saying that, or let's say we are 5, we went to do a job. And then on average, we were paid 500 cedis per person. On average, we were paid 500 cedis per person. What it means is that if you want to know the total revenue we are getting from the job, we only have to multiply the average revenue, which is the 500, by the quantity of persons or the number of persons that did the work. And so for you to get your total revenue in this example, you are just going to multiply the 500, which is the average per person, by the number of persons, which is the 5. So you do 500 times 5, and it gives you your total revenue. In the same sense, this question has given us an average revenue function of 14 minus x plus 3,400 over x. So for us to get our total revenue, we're going to do the average revenue times the quantity. And in this case, the quantity we said it is what? X. The unit of production here is X. So when we do 14 minus X plus 3,400 over X, multiplying X, it gives us our total revenue. And by expansion, we are going to get 14 times X, which will give us 14X. We will get negative X times X, which will give us negative X squared. And then 3,400 over X times X will give us a 3,400. So this gives us our total revenue function. Any confusion?
Yes, a lot of confusion.
A lot of confusion. I like that. So what we are saying is that we need to understand the relationship. We need to understand the relationship that exists between the total revenue concept, the marginal revenue concept, and the average revenue. It's just like if you have an average revenue, what the average revenue means is that on average, teachers are paid, let's say, 3,000 cedis a month. That's the average. And so a particular school, if you want to know the total salary being paid to teachers, you only pick the average salary and multiply it by the number of teachers in that particular school. Is that not the case?
Yes.
Yes. So we want to apply that same concept here in this step. Now, this question has given us the average revenue, which is this particular function. So the whole of this is the average revenue. So we're having the average revenue as 14 minus x plus 3,400 over x. Now we want to know the total revenue. All that we are saying is that we will multiply the average revenue times quantity. Again, this question places emphasis on the fact that the quantity we are talking about is x. And so average revenue times quantity simply means that we should write the average revenue function and multiply it by x. So the whole thing in the bracket times x, or is similar to rewriting x times 14 minus x plus 3,400x over x. In this case, the x here will multiply the 14 to be 14x. X will also multiply the negative x to be minus x squared. And then x will also multiply the 3,400 over x. In this case, the 3,400 over x times x. This will cancel. So we're going to have 3,400. And that is how we get the total revenue function. Is it clear now?
Very, very clear.
Okay. Then we use the same approach to get our total cost function. We use the same approach to get our total cost function. Here we are given the total average cost function. We are given the average cost function as x squared. So average cost is equal to x squared plus 15x plus 2,300 over x. For us to get the total cost, we do the same thing. We do x multiplying x squared plus 15x plus 2,300 over x. And that is going to give us x times x squared, which is going to be x cubed, plus x times 15x is going to give us 15x squared, and then x times 2,000, x times 2,300 over x is also going to give us 2,300. So this also becomes our total. Come again. This also becomes our total cost function. So we have our total revenue. Let me write them here. Total revenue is equal to 14x minus x squared plus 3,400. And then total cost also giving us x cubed plus 15x squared plus 2,300. Now we come back to how we were getting our profits. We come back to how we were getting our profits. Remember I said that the profit is when you take your total cost from your what? Total revenue. Do you remember?
Yes.
Yes. So in this case, our profit, which is symboled by this, is equal to total revenue minus total cost. Now our total revenue is 14x minus x squared plus 3,400 minus the whole of x cubed plus 15x plus 2,300. Then we simplify. So we're going to get 14x minus x squared plus 3,400. Now we expand the whole bracket with the negative. So we get negative x squared cubed minus 15x minus 2,300. Are we getting it up to this point?
Yes, please, Doc. Please, 15x. Should we 15x squared or 15x?
That is s squared, yes. So we have 15s squared here. So we now add like terms and then we do arrange them with the highest power. So the highest power is 3. So we bring our negative x cube here, this one, we bring it here, and then we do negative x square, negative 15x square. What do we get? Negative 16x square. So we have negative x square minus 15x square. Remember your laws of indices. You can only add or subtract terms with the same power. And so the one who said we are going to revise our calculator, we should also revise the laws of indices. So we are going to get x cubed minus 16x squared. And then we also have 14x squared here, 14x here, which is standing alone. So the 14x will come plus 14x. And then we also have 3,400 minus 2,300, which is also giving us a plus of 1,100. So this becomes our profit function. So for this particular question, before you go to the steps, before you go to the 4 steps that we looked at previously, you have to be able to determine the profit function as well as the total revenue function, because the question is in 2 folds. It says that we should maximize our profits and then we should maximize our what? Revenue. So once we have the profit function, then we can apply the 4 steps. The first step says that we should find the first derivative. Do you remember?
Yes, sir.
The room is quiet. Okay. So we will do our first derivative, which will be d pi over dx. We are differentiating this function. We have negative, the function is pi is equal to negative x cubed minus 16x squared plus 14x plus 100. So what do we get?
So the answer is negative 3x squared plus, sorry, my, let me see.
Take your time.
Negative 2 times 16. Okay, so it's negative 3x squared minus
minus 32x
minus 32
plus 14
x plus 14. That's right. Then the second step says that we should do what?
Equate to 0.
We equate to 0 and solve for x. So let's do that quickly. Let us equate it to 0 and solve for x.
Well, 6x minus 32.
Let's equate it to 0 and solve for x. So x1 will be what? And x2 will be equal to
one is 0.42.
0.42.
It's 0.4208 for the S2.
So let's say 0.42. 0.42 is what?
0.4208. So we
And
can make it
X1 is
0.2.
X1 is
0.42.
Coming.
Another one to is 0.87.
zero. The other one is
Negative 11.0.
so S2 is equal to negative 11 points.
0.8.
0.87.
0.87.
Yeah, 0.87.
Okay. Then what's the third step?
And the second derivative of
you find the second derivative. So you have to find the second derivative, d square y over dx square. That is when we are differentiating the first derivative. So we differentiate this one. What do we get? Shamili, I can hear you. I'm waiting for your answer.
For which one? Second
Negative
derivative.
6.
Is it 6x minus
Second
32?
derivative, negative 6.
6x minus
6x minus
32.
32.
6x minus 32. Okay. And what do we do after finding the second derivative?
We do the substitution.
We do the substitution. So let's substitute and see which one will give us negative. Because we are doing maximization, we want the x value that is going to give us a negative second derivative. And that is the answer. So let's do that and give me the values.
So please, the x2 answers 34.2.
I got 34.
The next one.
53.
Okay, it's close. And the first one.
It seems the same, but it's negative 34.52.
Negative.
So what will be your
So
conclusion?
just
Yeah.
What will be your conclusion? I'm waiting for the conclusion. I'm waiting on. What will be the conclusion? Step number 4. What does it say? Our time is giving up.
If the result
What
is
does step?
positive, it is a minimum 10 points.
And if it is negative?
And vice versa, if it's negative, it's maximum 10 points.
And what is our interest? We are to determine the what?
the profits and revenue.
We have to determine the maximum profit. And so the maximum profit, the quantity X to maximize our profits, is the one which gave us the negative second derivative. Do you get what I mean?
Yes, sir.
You are interested in the production units, the number of units of production, X. That will help us maximize our profit. So we are looking at the X value. That is giving us the negative second derivative. So in this case, the 0.4208 is giving us a negative second derivative. So we conclude that the quantity or the production unit of X to maximize our profit is 0.4208. Is that okay?
Okay.
All right. So,
Sir, please, how did you get the 0.42
that is where
on the
we,
conclusion? Yeah.
so that is the value of X. You remember the stage number 3, it says that we find the second derivative and substitute the values of X that we got in the second stage. You know how we got the X1 and the X2? Do you know that stage? How we got X1, how we got the X2? Or we go over it.
From the calculator.
We go over everything again. First, we did the first derivative, and then we equate it to 0 and solve for X using our calculator. And so when we get those X values, we want to confirm, because there are two values, we want to confirm which one is giving us the maximization, which one is giving us minimization. And for you to do that, you just have to find the second derivative and then substitute those values of X into it. The answer is the X. But which of the X? For us to know which of the two X, we need to do the second derivative to confirm. And by confirmation, we are looking at which of the X values that we substitute into the second derivative. And it gives us a negative answer. That is what we are concluding on. So when we substitute 0.4208 into the second derivative, it gives us a negative value. When we do substitute negative 11.087, it gives us a positive. And once we're talking about maximization, we will go with the one with the negative, which is the 0.4208. Is that okay? Anthony, you look like saying something, but we can't hear anything.
Oh no, I'm not saying anything. I'm just excited. I'm
So
excited.
let's pause here. Let's pause here, and then, as I mentioned, this is the solution anyway. You go through, I'll share the slides with you. You go through, and then I prefer we solving it as we have done. So before going through the slide solution, that at least you will know how each of the values were computed. So there is the steps. So alternative one, we go through to get this function, which is a profit function. And then once we have the profit function, we run through the various steps of getting the turning points, and then we are good to go. Then the second alternative, we will start our next class from here. The second alternative, where we will look at how we can use the second approach to also solve the same problem. And then we continue and then look at the integration aspect, which is very few, about 15 slides. Then we come back to probability. So we have probability to talk about, and then we have this final session to also to conclude our course. So I'll urge the reps, please let's try and sacrifice for the class and myself. Let's find 2 days within the week. At least communicate to me a day ahead of it, and then we can meet and then conclude on our discussion. Next weekend, I'm going to Sunyani. I'm going to teach the postgraduate students at Sunyani, and so it will be difficult for me to engage you in the afternoon as we usually meet. So please pardon me on this one and help me. So I'll be waiting for the message from the reps on which day we are to meet, and then we will meet accordingly. On that note, I will say good evening and then have a wonderful weekend.
Thank you.
Good evening, and thanks for the